Tangent theorem number 2. And it says if two segments from the same exterior point are tangent to a circle, then they're congruent. Okay, so let's see what that means. Okay, we've got a circle here, and we've got a point on the outside, and we've got two segments drawn to the circle that are tangent, so they touch in one place. I call this the party hat rule, which means that the two segments are congruent to each other. So now we're just going to take that and apply it with some algebra. So here we go. We've got the party hat rule going on. We got our circle, which I like to draw my smiley face in, and draw my party hat so you can see the two segments are congruent. So algebraically, I'm just going to set those two segments equal to each other. So we set up 11, or x squared plus 2 is equal to 11, so this segment has to be 11 too, because if that's 11, that's 11. So let's set up and solve for x. So I subtract 2 from both sides, so I get x squared is equal to 9. So x is equal to square root both sides 3. And it would be positive or negative, but we can't have a negative segment. So let's look. Can we plug a positive in there? Yes, because 3 squared is 9 plus 2 is 11. Can we plug a negative 3 in there and still get a positive answer? We can. So this ends up being both a positive and a negative 3 possible answers. Okay, so number 2, we've got these two segments. We're again going to set them equal to each other. So we have x squared minus 15 equals 14x. Now we don't know the length of either segment because they both have a variable, so you just set them equal to each other. Now this is a quadratic, so I'm going to have to get everything on the same side, descending order. So I'm going to move the 14 over, make it a negative 14, and bring my negative 15 to the back to get it in descending order. Now I can try to factor it. So what multiplies to 15 that has a difference of 14? And we know that those have to be 15 times 1, and we have to factor it into the two binomials. So let's see, I want a negative 15 and a positive 1, because that gives me a negative 14 equals 0. And to solve this quadratic, my answer would be x minus 15 equals 0. So x is 15, or x plus 1 equals 0. So x is negative 1. Let's make sure those work. Okay, positive 15. If I plug a positive 15 in both spots, I get positive answers. So that's a good answer. Let's try plugging in the negative. If I plug a negative in here, I get a negative 14. I can't have a negative length, so I have to throw that answer out. So in this problem, I only have one solution, and the answer is 15. Okay,